What's up, YouTube? My name is Johnny Bandon with Intrepid Technologies, and today I'll be going over route summarization with EIGRP. So let's get started. Today's video is a part of a series of videos that follows Intrepid Technologies' Confluence how-to page. So click the link below and let's get started. So first thing we're going to do is take a look at the Confluence how-to space. If you come down here to Cisco, click on Cisco routers and EIGRP. These are the video series of how-tos that I'll be going over. So today we'll be going over the route summarization how-to. So using this page as a guide, the first thing we will do is set up our lab environment. I'm using GNS3 to emulate viral routers, and I'm using INE's CCIE network diagram to build our network. Once our network environment is set up, we will continue with the how-to page and baseline all of our routers. Today, we will be using routers 10, routers 8, and routers 5 for the demonstration. So first thing I'm going to do is baseline these routers. As always, I'm going to go to the repository that I use for this lab. And using VS Code, I'm going to clone this repo and make sure that I have it for this video series. So first thing we're going to do is command palette. We're going to git clone using that URL. All right, we'll use the home folder as my repo location. We're going to open that up, and here we have the repository I use for this video series. Now let's actually go in and baseline our routers. So I'm going to console into R10, R8, and R5. So a part of this configuration, and I'll go to VS Code to show you this, I have made an applet on all the routers I use in this network diagram, or this network environment, to actually baseline my routers using an alias that will execute from privilege exec mode called baseline. So let's actually go into our routers and type in the alias baseline. We'll do R5. We'll do R8. And we'll do R10. And as you can see from the syslog messages in R8, we already got rid of a routing process that would be in our way for this configuration. So let's do a show run section event. Let's actually take a look at this applet. What is it actually doing? So first, we see here the alias I created. And it's going to be based off the event manager with this name, or the event manager applet. So we actually make this applet, event manager applet, the same name. We type in authorization bypass so we can get into privilege mode. There's going to be no event that triggers this applet because we're using an alias to run it. And as you can see here, these actions all I'm doing is simple CLI commands. So I'm getting rid of all the routing processes that I use in this lab. Okay, so now that we have baselined all of our routers, let's configure EIGRP. So first thing we're going to do is hop on router 10. We'll do a show IP interface brief. And we'll see all the addresses that we're going to advertise. So let's configure these with named EIGRP. And to make it easy, I'm going to go to VS Code to my repo. I'm going to click this folder, Quick CLI Commands. I'm going to click named EIGRP. I'm just going to copy this and run it into R10. And boom, we're done. Do the same thing for router 8. Do show IP interface brief. We're going to paste this, and just so you guys can get a clear look, these network statements, they're /16, and they will cover all the addresses on our router. So here I see we have one administratively down, and that's why we always do some basic checks of our router. That connection goes from R8 to R5, gig 0/1. So before we go any further in our lab, let me just get this set up. I'm going to no-shut that interface. And now we just saved ourselves some troubleshooting steps. Good. Now for a little bonus, I'm actually going to create an applet based off an alias to configure named EIGRP in router 5. This is just a little bonus so I can show you guys how these applets are actually made on the CLI. So first things first, let's make our alias. So here, we're going to put in, we'll just type in named EIGRP. So this will be what we actually type in at privileged exec mode. Actually, let's change that. I'm just going to put EIGRP. And then we're going to map it, so to speak, to an applet. So alias exec, the actual alias name. And this alias will trigger the event manager run. And we'll name that applet capital EIGRP. Boom, done, easy. So now let's actually create the applet. So we'll type in event manager, applet, the name, so EIGRP all caps, and remember this has to match. Authorization bypass. This allows us to get into privileged exec mode. There's going to be no triggering event because we're running it based off an alias. And now we get to the fun part. Action. And again, I do 3 digits, 001. This would also work as your first action. And this order does matter. In the event manager, it's going to be chronological in order for your actions. So first thing we're going to do is enable. Our second action will be to get into global configuration mode. Next, we're going to get into named EIGRP. We'll get into the address family for IPv4. To autonomous system 1. And remember guys, everything I'm doing matters. The order and the numbers I'm putting them in, and even these quotes right here. Now we're going to advertise our networks. So you see this? We made a mistake. I made both of these 004. So what are we going to do about this? What we can do, just know this out. Go back and just change it to 5. see here, action 005, CLI command, network 150.1.0. And that should have taken. We're going to advertise our last network here, 155.1.0.0, 255. We'll do one last action. And this right here, just make sure that we actually hit the return key. So now that we have created our applet, let's do a show run section event. So we're actually missing one of these statements. We're missing action 004. So what do? It's really easy to fix actually. We'll go in, copy paste, and since it's sequential in order, the 004 will go right in between 003 and 005. So we're missing the address dash family. And now we'll put it in there. Unicast, Thomas System 1. Got to make sure it's the right quotes. We'll exit. And we'll check just to make sure that everything is looking good now. And all right, we're in there. So let's type in our alias. Let's see EIGRP come up. Now I know this may look like a lot to do just to get EIGRP configured, but learning how to run these applets can save you a lot of time. And there's a lot of things these applets can do to make your life so much easier. So knowing the syntax for it is very important. Now that we have configured EIGRP, let's get to the actual configuration that we want to do for this video. Summarization. So out of these three routers, where do we want to summarize? So what we'll do is from R8 to R5, we will summarize our 155 addresses. We'll advertise a /16. This one right here, and this one right here. So in the routing table of R5, let's take a look at it. Show IP route EIGRP. We should see these two right now. And after summarization, we should only see one because we're going to summarize the /16. We're also going to do something else here. So I'm going to create another loopback on R10. I'm going to put it in that range, 155.1.16.1/24. And that should pop up in the routing table. Here we go. So I'm still going to advertise and summarize as a /16 for the 155.1 network. But we're going to do a little bonus in here. We're going to actually leak a /24 through our /16 summarization. The way we do this is through a leak map. And that leak map will be based off a route map. And that route map will be based off a prefix list that matches the address we want to leak through our summarization. So let's go and do this configuration. Again, we're doing this from R8, so that's where we will start. So first things first, we want to do a leak map through our summarization. Again, that leak map is based off a route map. And that route map can be based off a prefix list or even an access list. For this demonstration, I'm going to do a prefix list to match the /24 address that I want to leak through our summarization. So the syntax for that is as follows. IP prefix list, a name, we'll call it leaked. and then we're going to permit, and we're going to match the /24 address that we want to leak. So that'll be R8's loopback address. Boom, we're done there. And now we're going to create the route map. And again, this route map will be based off the prefix list, how we do our matching. So we'll name this route map leak Addy permit 10. That's just the sequence we have, and it's a permit statement. So we're going to allow this address, right, not deny. And we're going to match IP address, prefix list, and the name of our prefix list. And boom, we're done. So now let's actually do the summarization. What we're going to do is get in to our named EIGRP. We're going to choose our address family, IRP4, unicast, autonomous system 1. And we're going to go to the interface that's actually sending the routes to R5. So we're going to actually go to the interface advertising the routes to where we want to summarize. So AF interface, gig 0/1. And the syntax is summary address, 155.1, then the summarized address. And here we just do a /16. So if we type this in right here, R5 will only see a /16. It won't actually leak the /24 that we want to leak. So let's hit enter and see what we get on R5. So we see a graceful restart. That means our peer is resynced because it's sending a different route now. All we see is that /16. Whereas before, we had that classful address, but we also had the /24s underneath it. So now let's go ahead and actually leak. So the leak map name is going to be our route map name. So I believe I named it leak_Addy. And we should see a resync again, a graceful restart. And here we go. We have that /24 address. So again, guys, as far as route summarization, that is one way to do it. We used named EIGRP and we leaked a /24 address under that /16 summarization. That is all I have for this video. As a little bonus, for the next 5 minutes, I'm going to do a Wireshark capture on gig 01 from R5 to R8. So for those of you that want to stick around and watch it, please feel free. And for those of you that don't, I appreciate you coming. Thank you for your viewing. And remember to learn every single day. Now for those of you still with me, let's get into some sweet Wireshark action. So first thing we're going to do is on R8, I'm actually going to shut gig 0/1. I do this because I want a fresh packet capture. So let's start this capture. Ethernet, yep, from R8 to R5. This is going to launch Wireshark. So with that interface shut down, we have the source 155.1.58.5 just spamming hello messages. That .58.5 address is sourced from R5. So this interface is still up and is sending hello messages. We can see that in our packet capture. Let's actually take a look at one of these, what's in here. So again, this is just setting the EIGRP parameters. So it has our autonomous system number. It's going to have our K values. And of course, it's an actual hello message. And it's sending that on EIGRP's multicast address. So now let's actually go to R8 and no shut the interface. So let's see the fireworks. So first thing is going to ARP to get its neighbor. And now we're seeing the EIGRP hello messages go back and forth with the updates and the acknowledgements. So here at the wire, we're actually seeing neighborship form right now. So it looks like we've already formed our neighborship. As you can see here, after the hello is sent to that multicast address, and these routers are talking, it'll actually start doing a unicast push with hellos and acknowledgements. So from R8, I want to see its update. I want to see what it's actually sending R5. So again, let's look here. Actually, I want to do a source of R8, right? Because that's doing our summarization. So here we see one summarized route being sent across. We have our wide metric for named EIGRP. And here's the destination, the prefix length. That's our summarized route being sent. And then we also have the /24 that we let leak through. So that's what it actually looks like on the wire. So again, guys, thank you for coming to view my video. Wireshark's always a great learning tool to actually see what's happening to our packets. So again, thank you for viewing. And remember to continue to learn every single day.